that person. I'm not saying that those who consume alcohol is bad or good. Maybe coffee or tea. Maybe I can make it in this way. So consuming coffee or tea is all depends upon not only the price of it, it also depends upon the individual's perception. Some people, you know, they may not take garlic and onion, not because of price and all. Their individual characteristics matters. So if you're comparing variables on the things, there are certain variables which is qualitative in nature. Okay. So you can't leave this variable while computing any models or forecasting the things. So you have to adopt qualitative features into your model. So these models will serve the purpose. Okay. So response is going to be qualitative in nature. The best example for this is maybe good or bad. Okay. So if the response is in qualitative nature, which cannot be measured, measured with some other numbers in binary numbers, you have to incorporate those characteristics, those information in the model, then only get the opt model. If it told you as much of information as possible, then you can get the best model, right? So as I told you this tea and coffee example, right? In this models, what we are going to do is we are going to model the individual choice. An individual has a choice whether he can take coffee or not. Okay. Everybody, okay, maybe this example is too awkward. You people went for a tea, but I didn't join because I won't take tea. It's my choice, right? So why I'm not taking tea? If you want to model that, there are different variables. Why you are taking tea? There are certain different variables, right? So here we are going to model the individual choice. Generally, the choice may have only two options. Okay. Maybe yes or no. Right? It's going to be discrete in nature. If you want to ask, if you want to get some examples, you can look at here voting behavior. When a person can vote, he may not vote. Whether he prefers something, he may not prefer something. Whether generally this type of individual choice may be on whether or not decisions, whether you can take a decision or you are not taking a decision. So what we are going to do in this model is we are going to incorporate all this individual preferences in our modeling purpose. As of now, we have all the variables are quantitative in nature. Everything is quantified. Everything in numbers, even the tons or whatever it may be, everything in numbers. We simply compare the variables. But here, it is not simply numbers. These variables are not quantifiable. It is qualitative in nature. So we are going to incorporate these variables in our model because individual choice also plays a very important role in economic decisions, right? So how do we do that? So as I told you here, we are going to measure why the person is taking this choice or he is not taking the choice. Most of the cases you can come across, if you use this variable in the right-hand side of your equation, it is called as dummy variable, right? So using yes or no choices in your right-hand side of the equation, I'm telling you in a very layman's language, right-hand side of the equation, then it's going to be dummy variable. Instead, dependent variable itself a categorical variable. Simple terms you can map in this way. If your dependent variable is dummy variable, what you can do? It's not having continuous variable, right? It's a discrete variable, 1 or 0. What is dummy variable? If a person possesses some character, you can give 1. If he's not having that character, you're going to give 0. Right? If that is the case, you know how we can use the dummy variable. We can go for interactive dummy and we can, based on the content, we can interpret this dummy. But in the special case, if your dependent variable itself 1, 0, it is not continuous, how can you deal with that? In this case, you can't apply your simple OS, right? So you have to look for a different model. Or in this case, the standard regression methods are inappropriate. You can't apply the standard regression model. For that, I think all of you know what we are doing in a standard regression model. We are trying to measure what is the conditional mean of the regression. What is this? Beta? Beta is nothing but the conditional mean of this regression coefficient, right? But in this type of model, we are not going to measure the conditional mean of the regression equations. We are going to measure what is the probability of happening and what is the probability of not happening. Right? Clear? Here, the coefficients alpha or beta is not going to say what is that? Degree of responsiveness. It is not going to say the elasticity. It's going to tell you what is the probability of happening the event, right? What is the difference? So why? Because in your left-hand side, your dependent variable is only either you can take the choice, you are not taking the choice. This coefficient will tell you what is the probability of taking the choice. This probability will tell you what is the probability of not taking the choice, right? Here it is not saying 1% increase in this will go into this much. It is not the case, right? So this is what we are going to do in this model. This model is going to model the probability of events, right? That's what I'm highlighting here. This model is also called as QR model. It is nothing but quantitative response model. The response is response are quantitative in nature, right? It is going to estimate the probabilistic statements. It is not going to estimate.
402870983. Saxi message. I just had a word with Dale itself. He said, let him check it out.
No, he don't know the story. Yes,
When did you talk to him?
by seeing that he's trying to somebody. I tell you, he wanted to say that.
Sorry. No issues. I think he's asking question to me. So if you understand this basics, that is very important. First thing is here, the dependent variable are going to be in choices, one or two. It's going to measure why the event is happening, the event is not happening. First point. Second point is here we are not going to test any, what is that? We're not going to check the conditional mean of the variables. We are going to check the probability of happening and not happening the event. If this is the model, your simple OLS method won't be appropriate. You have to look for different modes, right? Okay. Before entering the binary choice model, the quantitative response model, let us have a quick revision of the structure it's having. Usually, the quantitative response model, you may have this much of choices. One is the model may be binary. You know what is binary, right? Here we have only two choices. Either you can take it or you will not take it. You have only two choices. Second thing is multinomial choice. What is multinomial choice? Here you have more than two choices. For example, if I ask you whether you want to have it or not, you can say yes or no. You can say possible, it's not possible. So there is no third option. That is called a binary choice model. In multinomial choice model, an individual will have more than two choices. Suppose if you want to travel, you have a lot of choices. You can take a road, you can take a rail route, you can go by air, you can go by even sea also, right? So there are different possibilities for that. So in multinomial choice model, you may have more than two choices. So just remember the thing here, your dependent variable is going to be binary, dependent variable, whether or not choices. Whether or not choice may be one or two, only two possibilities. It may be more than two possibilities. If it is more than two possibilities, then it is going to be multinomial model. The third one is ordered choice. The very basic thing of any research is you have to declare how your data is allowable. We have different types of data pattern. One is nominal. I think all of you know about this, right? Ordinal, nominal. What is ordinal and nominal?
Order have the importance.
Okay, exactly. In nominal variable, 1, 0 does not have any sense. 1 is 0. But in ordered thing, 1 is greater than 2. Greater than 3. For example, ranking. Suppose in gender wise, I am saying 1, 0, it does not make any sense, right? It's just a number. But in the class ranking, if you score first rank, second rank, it has meaning, right? So in the order thing, if you have a choice, you can order it based on the preferences. If I give you different foods, vegetarian food, non-vegetarian food, you can take a choice, right? A non-veg may give the first preference to vegetarian. A vegetarian may pick the first preference to vegetarian, right? So this is the choice. This may be based on ordered choice also. Here, it's the numbers are arranged based on preferences. Final thing is even counts. See, suppose this type of data will assess how many times you make a visit to a physician, how many times you're going to a gym in a month. Let me take this example. This even counts. The best example is how many times a particular event is happening. How many times in a month you are going to a doctor. If you're going very frequently, then you're sick, right? So that may be, suppose if you want to measure what are the factors determining number of visits to the doctor. In that case, if a binary choice model won't help. You can't go for yes or no also. Okay. The question is how many times, what determines the number of visits to the doctor. There you can't keep 1, 0. There also you can't keep multinomial. There also you can't keep order. There you are supposed to go for counts. How many times you are going? 5 times or 6 times. Somebody will say that in a year I'm going for 5 times. Somebody will say 10 times. So that even counts will count how many times a particular event is happening. So these are some of the possible framework of your quantitative response model. Your quantitative response model fall in any one of this thing. Okay. Binary choice, we have only two things. Every model associated with this. Binary model maybe become we are going to talk about only a binomial logic model. It may be multinomial also. Multinomial, the choice are different. That's around time series. I'm not going to touch that part. The only thing is here, our choice in this discussion, I'm going to talk about only the binary choice. I'm not going to talk about multinomial. I'm not going to talk about ordered choice or even sampling. But those things are a separate knowledge. Okay. Most of the cases, if you're dealing with observation research, you end up with multinomial only. Binomial choice are very limited. Right? Generally, if you're dealing with HR type, HR research on HR questions and then marketing and all, you have a lot of choices. So the important thing is, as I told you, this if you have such a regression setup, where the dependent variable is a quantitative response model, you can't apply simple OLS. If you are doing so, then it's going to be inappropriate. Why? Because here we are not measuring the event. We are measuring the name of the event. We are not look at the final the point before the final point. Here we are not capturing the event itself. We are just naming the event itself. Getting the point? It is not exact event. We are just named the event with some other thing. That is what linear regression is not appropriate for here. Even though all this model having some common elements among themselves, they are also having substantial differentiations among yourself. You can't interpret a binary choice model at the same way how you're interpreting the multinomial choice model. Both the things are different. Okay. That's something called as odds ratio. If you're somebody who works on, it's purely on, I'm not touching any panel, it's purely time series. But without knowing Logit and Probit model, you can't understand how it will operate in panel models. Right? That's what I'm revising all those things. There is something called as odds ratio. How you are defining odds ratio in binary choice model differ from multinomial choice model. So you have to be very careful about how you are defining how you're interpreting the results. Thing is, a lot of things are common the same way, a lot of substantial differences also there. Right, man. This is the thing. Suppose you have a quantitative response model and you approach this. Then you can approach directly a simple OLS method. Whether can apply the OLS procedures what you are using with your classical linear regression model assumptions. Whether the inferences what you are going to make from this model are reliable. How can you measure the goodness of fit of the model? What is goodness of the fit? I already told you we have separate model. You have to pick a model among them from based on this goodness of fit. So whether if you have a quantitative response model, whether whatever apply for time simple linear regression model is applicable here or not. That's a very serious question. The answer is no. Okay. You can't apply your simple OLS testing procedures, okay, to the quantitative response model. If you are doing so, whatever estimates you are getting is not reliable. It is not. It's nowhere connected, right? So if this is the case, how can you solve this? You have a problem of, you have an issue, you have a model, something like quantitative response model. How can you deal with that? If you have a quantitative response model, then you can use any one of the following models. This something called as LPM, linear probability model. Second one is Logit model. The third one is the Probit model. This Probit model. I'm not going to talk about everything. Okay. Each and every model serve different purpose. My concern is only on Logit and Probit. Maybe I can, even I don't know whether I can cover panel structure of this, but I can give you the basic idea how it works. So linear probability model. What is linear probability model? The name itself will tell you linear probability model. See, the basic thing is in a linear probability model, what we used to do is we simply apply the linear techniques to that without considering anything. Okay, even though the y is a dichotomous variable, 0 and 1. Okay, getting the point. I already told you we can't apply it, but in linear probability model, what we used to do is we simply apply simple OLS. But your dependent variable is going to be dichotomous. It's going to be 0 or 1. If you are doing so, whether it is right or wrong, you see we discussed initially, nothing is going to be correct. The fundamental problem with linear probability model is the errors what you are estimating is going to be normality. you know that the first condition of classical linear regression model is the error must be normally distributed. If you are applying linear probability model to your what is that? Quantitative response model, the errors what you are getting is not going to be normally distributed. The first condition is itself gone. Second thing is heteroscedasticity. What is heteroscedasticity? Actually, we have a condition called as homoscedasticity. What it means that the errors, the variance of the errors are not time varying. The variance of the errors are constant. Second assumption, homoscedasticity. The variance of the error must be time invariant. The standard error, the variance of the errors must be time invariant. Okay. If this condition is not satisfied, then we have the problem of heteroscedasticity. In time series econometrics, you all know there's a person called Angel and Granger. They tried to model this. For that, they got Nobel Prize in the year 1981. Heteroscedasticity is the problem of not satisfying the condition of homoscedasticity. I'm not going into that. So if you have, if you're applying a linear programming model that is a simple linear regression to the quantitative response model, first thing is your errors will not satisfy the condition of normality. Second thing is you have the problem of heteroscedasticity, right? Even these two things sometimes possibly can be managed if you're applying either WLS or GLS. I think all of you know about WLS and GLS. What is WLS? Weighted least square method. Another one is GLS, generalized least square method. These two things may be sorted out by using these two methods, but the final two problem is the villain of the model. First thing is possibility of estimating y hat. It is supposed to be y hat, right? The typo is y hat. I think all of you know about what is y hat, y cap. Okay. This part is nothing but the y cap, right? So what is our structure of our model? Structure of model assume that we will take only the value of 0 and 1. Sometimes this thing that y hat itself will not fall into the range of 0, 1. It may be less than 0, it may be negative, it may be greater than 1 also. If that is the case, if our entire model structure is wrong. I'm getting the point. We're applying LPM. Sometimes what we used to do, we don't know what is the exact value. We have the estimated value as the error term. We'll give you the original value. That estimated value is called as y hat. Sometimes what happens is if you are applying LPM to this, the estimated value of y may fall less than 0. It may be higher than 1 also, but by theory, but technically the value must lie between 0 to 1. If you take a choice, then it's going to be 1. If you not take the choice, it's going to be 0. But the estimated y hat may be less than 0. It may be minus 0.2. It may be 1.3 also. Technically, it does not have any logic, but we may end up with those problems if you're applying this simple linear regression for quantitative response model. Or getting the point. The base itself will be questionable. Third point is this, a very important point. Based on this, only the entire quantitative response model is assuming. See, this linear assumption, we have an assumption in our classical linear regression model. It assumes that if there is any change in x, okay, one unit change in x will cause certain amount of unit in y constantly throughout the period, right? Getting the point. If 1 unit change in x will lead to change in y by certain amount throughout the period. But here it is not the case. Take an example of housing. Okay, if somebody is not having home, we give them 0. If somebody having home, we'll give them 1. Okay. So what determines, suppose if it's not only what factor determining your housing, it's nothing but your income, right? Suppose you have, say, 10 lakh crore rupees of income. Let me ask this question. What it says is that the impact of one variable on the other is constant, but that is not happening in the reality. For example, if people have more income, we assume that if income increases, housing numbers will increase. If people does not have income means the possibility of having house is 0. If people have high income means the possibility of having house is 1. Let us assume in this way. How many houses Ambani may have? He has lakhs and lakhs of crores of rupees, right? So he has lakhs and lakhs of houses or what? At a certain point of time, if income increases, there is no possibility of increasing houses also, right? It has only threshold limit. Beyond that, it won't go. But this model assumes that the change in independent variable for a change in dependent variable is going to be constant throughout the thing. But that is not possible. This is a very serious assumption. Let's have a look here. The marginal increment of X remains constant throughout the period, but it's not the case. That's the threshold limit. Beyond that, it won't happen. So if that is the case, if you apply minus to this model, then it's going to be a serious problem. This is one of the serious problem of LPM. How do we solve this? Solving this, we have a set of other quantitative response models. As I told you, the other issues of LPM can be managed by applying the other method of estimation like GLS or WLS, but these two things never. The first thing is the probability value of 0, 1 maybe fall outside the interval. This cannot be managed. Second thing is we have to identify a model where the probability value of 0, 1 may not be lied outside the range. If you estimate the model, the estimated y hat must be lies between this thing. We are supposed to need a model with such criteria. What are the two criteria? First one is if we estimate the model, the estimated y hat must lies between 0 to 1. It's not supposed to be negative. It's not supposed to be greater than 1 also. First condition. Second condition is the relationship between the probability P and X is supposed to be non-linear. Right? It's supposed to be in this nature. So now, whatever we discuss, the models are talking about linear relationship. X increases. If time increases, what happens to this variable? It's keep on increasing. But in this variable, it is not the case. X increases, initially it falls. Then it's increasing. Then it may come down also. It is non-linear. It is linear relationship. Models, if you have a quantitative response model, applying LPM will end up with such an issues. If you want to solve that, we need the other type of response model where the first condition, 0, 1 value may not be fall outside that. The second thing is the relationship between the dependent variable and independent variable must be non-linear. So what are those models? As I told you, there are different types of models out there. The most popular models are Probit, Logit, and Probit. I'm not going to talk about Probit. Probit is completely different model. Right? I'm not teaching panel. I'm teaching only time series. No other choice. Right? So if you don't know anything, I can give you the equations. Means you can't understand. That's a very serious issue. How these models are different from LPM? How these models are different from linear probability models? The first thing is for every model. I will show you that. Okay, every model have a distribution. I think you know about cumulative distributed function of the model. Okay, maybe you can go and see what are distribution functions, theoretical distributions are there. Okay, every model have a distributions. Okay, so every model has the probability distribution function. If a model assume that a distribution function, I will show you that. Maybe one or two equations I can show you that. If a model assume that it's a distribution function is in logistic form, it's called as Logit model. The model assumes that the distribution function is normal distributed. If a probability distribution is normally distributed, then it is going to be Probit model. Then you may have a question from all your faces. I can understand what is probability distribution. See, what are the possible values you can get here in the quantitative response model? 0, 1. How can we get this? Getting this value is tied up with some function, right? We are supposed to get only 0, 1. If we are getting 0, 1 based on the logistic function, then if the model assumed in that way, that model are called as logistic model. If that getting the probability of 0, 1, the possibility of happening the event and not happening the event is based on normal distributed probability models, then it's going to be Probit model. I will show you that. We have two equations. That is good enough, right? I'm getting the point. So if the probability of happening the event following the logistic distribution, then that model is called as logistic model. What is the probability of happening the event? 0, 1. If the probability of happening 0 and 1 is based on distributed function of logistic, then it is going to be called as Logit model. If the distribution of probability of happening the event is assumed as normally distributed, then it's also called as Probit model. It's also called as NOMIT model, NOMIT. Yes.
Logistic distribution.
I'll come to that. I will show you because I want to show you that at least. Right? So if you want to understand logistic distribution function, you have to understand what is going to be the function of LPM. What is the function of Probit? Then only you can understand. I will come to that. So is it clear? See, I will make it in a very simple way. We are having the model where the dependent variable are going to be quantitative response. It may be 0, 1. Okay. What are the chances are happening here? 0, 1. The probability value may be 0, it may be 1. So how can you get 0, 1? If getting the 0, 1 is based on a function called as logistic function. It is called as logit model. If you assume that getting 0, 1 is based on the function called as normally distributed function, it is called as Probit model or Nomit model, NOMIT model. Right? That is one case. A very important difference of this model from our other conventional model is here we are supposed to apply maximum likelihood estimates. It is not based on OLS estimates. I think all of you know about difference between maximum likelihood method and OLS estimates. Do you are aware of it about? See, suppose you are estimating this model y is equal to a plus bx. Our ultimate purpose is to get alpha and beta. Right? If we want to get this, how can we get this? We have a method called the method of least squares. We can solve this equation. The sigma y is equal to na plus bx. Then other thing we can obtain these models. The method of computing this is called as method of least square. Okay. The ultimate method purpose of that method of least square is to minimize the errors. Okay. Why? Because we have an error. If the error term is high, then the model reliability is going to be questionable. So the purpose of least square method is to minimize the errors, right? So it is not the only method available. There are a few more methods are available to obtain this alpha and beta coefficients. If you want to obtain this alpha and beta, it is not only OLS is available. There are other methods, something called as maximum likelihood method. There are other methods called as Bayesian estimations are there. Cupola estimations. So there is a lot of methods are there. OLS is very simple to apply, very easy to understand. So every text are following this. Even maximum likelihood method, I don't have much hold on it because the purpose is different. In OLS, we are trying to minimize the error, whereas here we are trying to maximize the likelihoods. So you have to understand what is likelihood. I'm not going to touch that part. Okay, the purpose are different. This logistic and Probit model, we are supposed to use maximum likelihood method. It is called as ML method, not OLS method. Okay, this is the major difference among this thing. Okay. Time. Maybe I can tell you what is. I can use this board for 5 minutes. Okay, let me finish this because after this it will take 1 hour to cover everything. So what happened is we have a logit model and we have a Probit model. Sorry, it's not Probit. It is supposed to be Probit. It's a typo. It's not Probit. Generally, Probit will bypass Probit because that model was proposed by James Tobin. You know James Tobin, right? James Tobin, Tobin's Q theory. He's the one who proposes model. So whenever I talk about Logit and Probit models, Tobin will bypass him because I'm a great admirer of Tobin. He wrote a very fantastic book on macroeconomics. So whenever I try to say Probit, Tobin will come to my mind. So that is what, even while typing, I typed as Tobin. It's not Tobin, it's Probit. Okay. So what we are having here is, we are having a logistic regression, logit model, or a fixed effect model. If we have following the fixed effect estimations, that's a separate set of models, logit models are there. You have to estimate in a different way. Suppose you are estimating random effect model, the estimation of logit model is different. Just remember this, it is not Probit, it is Probit. It's a type. Okay, so what the point here is, if you are estimating logit model, okay, under fixed effect criteria, we have a different estimation process. If you're estimating logit model and the random effects model, then we have a different estimation process. Like that, if you have a fixed effects in a Probit model, then we have a different purpose. If you have random effects in a Probit model, we have a different purpose, right? So let me tell you how this Logit, Probit, and Probit model differ. I don't know whether. Let me explain this, then I can move on. So what is the difference between Logit model and Probit model? There is a proper distribution is there, but still in one single line, we can assume the Logit model assumes that the probability distribution of happening the event is logistically distributed. Whereas in Probit model, it assumes that the probability of happening the event is normally distributed. Then what is Probit model? Probit model is a right? X and Y for different set of groups. Sometimes what happens is you have, let me tell you five groups: group 1, group 2, group 3, group 4, and group 5. For all these groups, you are collecting income and consumption data. Suppose sometimes what happens is in a panel setup, for group 3 and group 5, you don't have income data, but you have only the consumption data. In such case, what you used to do? We simply leave group 3 and group 5, we estimated, but that is not correct. Those type of data is called as censored data. If you have such a data setup, Probit model will come and help. Getting the point? That is what I'm not touching that. See, generally what we used to do, if you're estimating a model, we have both X and Y for all the groups, states. Here in some states, you have only one variable, the rest of the variables may not be there. Those type of data sets is called as censored data or truncated data, if I'm right. So if you have such a data set, there is a possibility, right? If you're dealing with panel, certain data sets may not be available for all the countries, but still those information are required. If you have such a data set, then Probit model may be useful. Or getting the point. The difference is I will show you the equation, but you understand what is Logit model? In Logit model, we assume that the probability of happening the event is following the probability distribution of logistic. It is called as Logit model. If in the Probit model, in the Probit model, we assume that the probability of happening the event is following the normal distribution. Then, in that situation, you are applying Probit model. If you have a truncated data, censored data, then you can put Probit model. Here, the distribution is purely normal, normally distributed. So let me show you those two things. So I'm not touching any part here of time constraint, right? But still, you can have a look on this. So what is, just a minute. Actually, I picked this equation on Gujarati only. If you can have that book, you can even just have a look of those equations in English. Y is equal to 8 plus x plus. What's happening here is just listen. What are the, here we are using quantity response model. What are the possible value of y? Y may be one means what? The event is happening. Y 0 means the event is not happening. So what is the probability of it? What is the probability of it? The event is happening, so we can write this in this way. So probability of happening this event if y is equal to 1. If the y is going to be 1, then its probability is going to be something like this. Probability of y is equal to 1 by x. This follows the function of minus beta. Very simple logic. If the value of the event is going to be 1, then the probability function is going to be this. Right? It follows this probability function. If you want to understand this, just spend some time on theory of distribution. What is correlative distribution? You can find something like this, like sigma plot and all. So even those parts. So just remember this. It's a simple linear probability model. If event is going to happen, follows this. Right? The event is not going to happen. Right? In this case, going to be follow the function of here equal to 1 by x 1 minus the point. So you know that it's very simple probability. P plus Q is equal to 1. Q is going to be the same logic here. This is the chance of happening the event. What are the chance of not happening the event? So if you plot this, this is going to be in this range. You clear? This is the probability function. You're applying simple linear regression model, LPM model. It assumes it follows this probability function. If you want to get 1, then this is the probability function. If you want to get 0, then it is going to be the probability function. Is it clear? Is it clear? So this is for LPM. So now I'm answering your question. You are asking what is the probability function of logistic model. So what is the difference between Logit model, Probit model, and this LPM? Logit model and Probit model, we are following non-linear relationship. It is a linear probability function. So the first condition is the probability function is not going to be linear. So suppose if you have a functions, the same model, 1 plus 2. Happening of the event is y1. Happening of the event is y. Just listen. What happening of the event is y0. Follow such a function. Right. In this case, if one is happening means this is the probability. Suppose you have a model where if 1 is supposed to happen, then it follows this function. What is the difference between these two? The linear function, the non-linear function. Getting the point. If the happening of y is equal to 1 belongs to this probability distribution, then it is called as logistic model. It is not the end. We have other distribution, but for the sake of understanding, I'm giving this. You will understand. See, initially, this is the function. If one is there are 2 different types of model. In one model, we are assuming that the probability of happening the event is this. Okay. In other model, we are assuming that probability of happening of event is this. Here, the probability is linear in nature. Here, the probability is non-linear. If this is the case, you can't apply any of the simple OLS method because the probability of event following the non-linear distribution. But if the non-linear nature, you can't apply simple OLS, then you have to look for the other model. The other model is Logit model. Follows this distribution. Okay. Assume that this distribution is normally distributed with other distribution, then you can go for Probit. Is it clear? Are you able to understand? Yes. Not Probit, Probit. Probit is for censored or truncated data. Censored data means suppose you have X and Y. I already told you that 5 states, 2 variables. For one state, you have only 1 variable, other variable is not there, then it is called a censored data. Is it clear? Actually, there is one more thing. That's one minute. So we have, if you want to apply a Logit model for fixed effects, you have a different estimation. You want to apply Logit model for random effects, you have a different estimation. Right? The estimation processes are different. Testing process is also different. One important point is, as I told you, let us assume this is the model. Listen, all of you. Let me check the level of understanding following it up. This is the model. Okay. I'm assuming the happening of the events following this distribution. Is it clear? So what is beta here? B. It's B. How can you explain the beta? I told you very beginning, here the beta is not talking about 1 unit change in X, is not 1 unit change in Y. Probability of happening the event. If this will tell you, suppose it is 0.2 means it will tell you if 1 unit of change in X, how much times the probability of event is happening, Y is happening. But getting the point, it is that's what I show you, the probability of events. It is not simple response variable. It is not simple elasticity variable, right? Is it clear? So it measures the issue of probability. So that ratio is called as odds ratio, ODDS, odds ratio. What is the odds ratio? Odds ratio will tell you what is the probability of happening the event to the ratio of not happening the event. But getting the point. See, actually, I supposed to teach you panel Logit and Probit model, but I'm teaching you time series. Sorry. odds ratio. Oh, the problem in the odds ratio is you can't interpret this ratio in terms of coefficients. Suppose to explain in terms of probabilities. Sometimes we may end up with some kind of difficulties. But still, you can convert this odds ratio into simple coefficients. You get the odds ratio, but you can convert this odds ratio like a simple regression coefficients by taking the log of it. If you take the log of it, then that's odds ratio become the coefficients, the elasticity, the response, right? The time is 1:15. Okay. But I didn't cover anything on panel